Well, good morning, everyone. It's wonderful, and I must admit, it's a little bit overwhelming to be back in person. This is my first time coming back to the conferences out of the gate. All right, so Rewire for data mesh. Raise your hand if you don't know much about data mesh. And it's not about shaming you. I just want to know how quickly I need to breeze through the first part. Okay, it's probably 15%. Raise your hand if you are implementing data mesh for your organization or your clients' organizations. Equally the same number of people. I would have expected a little bit more. And keep your hands up if you think you have cracked the code of implementing data mesh. None, as I had expected. So hopefully this has some lessons to take away. I was introduced. Thank you for that introduction. Those are the two books. If you squint really hard, I have put a couple of links where you can get those books for free on O'Reilly platform. I've heard also Starburst giving out free books, so you can go to their exhibition stall and get them. All right. Why we should talk about data mesh? Why do we have a data mesh theater this year here? Because we are at an inflection point. If you look at this diagram, what you see on the x-axis is the increase in the scale of complexity of organization, the increase of uncertainty in our businesses. Maybe one measure of complexity is the proliferation of data sources, is the diversity of how we want to apply data. We moved away from just doing a few BI or kind of niche use cases for data, and we want to apply data ubiquitously in every function of our application. And what we see is that existing approaches or paradigms in managing data and getting value from data is plateauing. And I'm measuring the plateau by the ratio of value to cost, agility in response to growth. As you're growing, how quickly can you respond to change, and resiliency to change. So data mesh as an approach embraces this complexity as a default state of being, and it introduces a new way to get value from data at scale. And that plateauing is both based on my personal observations as well as industry stats. And I think by now you've seen quite a few stats thrown at you. I'm throwing another one. This is from New Vantage Partners. I keep an eye on these folks. And I guess what you see on this diagram is the universal spending that companies are doing on data and AI, and quite a lot of money, like 62% of organizations that this top 600 companies that they survey, is spending more than $50 million on data and AI platform. And compared to that spending, we're not seeing the widespread adoption. We're only seeing 24% widespread adoption of data AI in production, and less than half of people are actually competing over data. So what is going on? I think what's going on is that we have spent quite a lot of time and money over the last decade optimize our solutions for machine, and rightly so, right? We addressed the scale of volume in the early 2000s with the Hadoop. We addressed the scale of diversity of data with various object store, time series store, document store, various storage size. We addressed the velocity of sensor data and streaming with the streaming backbones that we have today with Kafkas of the world and pulsars and so on. But what we haven't addressed is the complexity, respond to scale of complexity of data in our organizations. So why the existing paradigms are giving us plateau in terms of getting results? Well, this is almost the state of the art, right? You have sources of data within or across the boundaries of your organization. You've got value to be retrieved from that data. And in the middle, you've got this centralized bottleneck. And I know I've comically simplified this picture just to get a point. There are three fundamental problems with how we have imagined how we manage data and get value from it. We've got data teams. We've got data lakehouse, data warehouse, the technologies that have been naturally built for a very centralized approach. And then we have this pipeline model. Data shall come from these various applications and sources, from real-world businesses, digital systems that's running the business, go through pipelines, get cleansed, get transformed, put into some form of a centralized storage, and then that's not it. Then layer it with governance, layer it with metadata, layer it with knowledge. Finally, pop out the other end, value. We apply the machine learning model. We train the machine learning model by making inference, or we're creating insights. And what's, I guess, in my drawing, what's obvious is that this process is fragile, it's full of friction, and it's functionally siloed. So I think in reality, that orderly design diagram that I showed you is less of what we see, and what we really see in the existing data architecture or approach to data is the architecture of Tower of Babel. Who has heard the story of Tower of Babel? Yeah, quite a few people. So the people have decided to make this big, tall, large tower, the city of Babel, that would reach the heaven. But the problem was they didn't speak the same language, so they created this confused architecture. And what does this have to do anything with how we manage data? Just to entertain yourself, pick up your technology provider of choice, go to their website. They have probably an allocated page that says custom connectors. I did that for amusing myself last night with a portable up-and-coming startup, and they have 296 custom connectors to connect to various different sources. And probably if I refresh the page, that had jumped up maybe to 300. So we're lacking open standards, and more importantly, we're lacking incentives to actually allow access to data, to run computation on different sources. So we get an architecture that looks like this brilliant 1600 Flemish painting of an architecture that barely holds itself together. A symbol of human condition, ambition and foolishness. So, what is about data mesh? Okay, we said data mesh wants to embrace the natural complexity that exists in organizations. How is it try to address those three problems that we see, three root causes? First and foremost, it tries to address the problem of centralization with a decentralized, domain-oriented ownership of the data and architecture to share data, so that cross-functional team, the teams that are building the digital system, the teams that are delivering business outcome, are responsible also for sharing data for analytical use cases or applying analytics embedded. How do they do that? Well, we create a new concept. We call it a data product, data as a product, a concept that encapsulates all of the structural components needed to actually reduce that lead time from data to value by localizing complexity in this unit. The unit that composes the data, the metadata, the documentation, the computation that happens on the data to make the data available. And most importantly, how do we then get access to data? We have to think about a new generation of APIs, not APIs that lets you access files or access tables, but a new generation of APIs that lets you run analytics distributedly on these computational data products. So initially, this has been discussed as 4 principles. The model that I shared with you, 4 principles that underpins data mesh are domain ownership, so breaking out the responsibility of data ownership and architecture around the seams of your business so that you can scale out as your business scales. Inversing our relationship with data, so we don't just see data as an asset to collect, we see data as a product to share and delight the experience of the users. Making it feasible for domain teams to work with data products and share them and use them by elevating what we call data infrastructure and abstraction levels. And a new model of governance that relies on embedded computational policies in each of these computational data products. There is a lot said here. There's 365 pages of a book that describes all of this. And of course, what we've seen over the last few years is that the industry has responded overwhelmingly positive to this idea. And my hypothesis for that is that the problems, the pain points that data mesh surface is ubiquitous, and also the principles are familiar. We have seen decentralized domain ownership modeling, API-based capability sharing. We've seen all of this happen 10, 15 years ago as we moved to kind of microservices and distributed architecture. We're just applying this to data. So I put some logos here as companies that are implementing data mesh. I see Max in his famous yellow jacket back there. He's from Zalando. We'll be talking about his effort there. Really, you can throw a stone and probably you hit a data mesh strategy in some company, no matter which direction you throw the stone. And if Google is an indication of level of interest, you will see that we are seeing growth in terms of interest in data mesh. Community. A community of learners have formed, and it is growing. Every time I have to refresh this page, I have to kind of see how many new people we have. In over just a year and a half, under 2 years, we've got 6,600 people that joined the community. I have to give a shout out to Scott Herleman, who runs it, meetups, podcasts, the Slack, newsletter, and so on. So please feel free to join the community, and of course, the vendors have leaned in. Again, the icons that I've put up here, by no means an embracement or criticism, is just to show that you have asked and they have responded. But what we see is not a complete pivot, but we're seeing incremental implementations and features being added. So AWS worked really hard to allow to use cross-account data sharing on top of the lake formation, a stepping stone toward data mesh. Google has Dataplex, again, a stepping stone for data sharing across different sources. Starburst adding features to their federated query to allow materializing views with extra metadata, and so on and so on. But are we there yet? I define data mesh as this. Data mesh is a decentralized socio-technical approach for sharing, accessing, managing analytical data within organization and across the boundaries of organizations. Have we got there? The vendors leaned in, the community responded, we are adopting. I don't think so. I think we still have quite a bit to go, and I want to share some of the anti-patterns that I've seen in the wild. On the socio part of it, on the organizational side of it, I've seen data mesh initiatives is still siloed to the data department. It's still a strategy, owned and driven and budgeted by chief data officer, chief data analytics officers. The digital app and services teams are still fairly oblivious in what's happening in terms of sharing data and getting ownership of the data. And this is perhaps natural. This is perhaps where we are in that spectrum evolution. So what's those atomic steps that we can take to get to that target state of decentralized data sharing? Well, we can start with, on the organizational side, we can start with adjusting incentives. If you look at LinkedIn, it's quite actually interesting. There's a lot of jobs being posted as data product owners, a role that data mesh introduces. But a lot of these data product owners, actually, are there any data product owners here? Before I spill a little bit on the job, so hopefully there will be none here. But a lot of the data product owners, they have a very tough task of sharing data for analytics across the organization, really understand the needs that haven't even come to exist, right? Because the use cases of the future needs to tap into the data in the past. So designing data, modeling data for something you can't even imagine is quite a job. But to incentivize, we should move away from incentivizing around how many data products you have and how much data you have to the usage of that data product, to the delight of that data product for the users. And also, we can start with moving our teams. Many of you are familiar, perhaps, with Conway's Law, Melvin Conway in 1967. Hands up if you are familiar with this. Quite a few people. So computer programmer Melvin Conway in 1967 observed that a lot of organizations that design systems broadly defined, their systems mimic the structure and communication structure of their team structure, communication structure of the organization. So we can do an inverse Conway's maneuver defined by James Lewis at ThoughtWorks, my ex-employer, so that we can move our teams in a way that it will drive the architecture that we want to have. So we start by moving this data product ownership responsibility into the domain digital teams and augmenting them with the capabilities that they need. So at the end, we get this isomorphism between the organizational structure and architecture. But no matter what we do, artificially create incentives around delight of the data users, moving people around to force the architecture to mimic the organization, none of this will work if people don't have those intrinsic motivations for sharing data, and that intrinsic motivation comes from need. And unless we embed insights, data science, machine learning, application of machine learning into every digital domain, into every application team, we're back to square one. And I think that requires embedding data science as well as data sharing into the domains itself. And of course, it's a tough task because you might say, wow, where would I get all these hundreds of data science teams? So there are technologies that are putting kind of data science in the box, modular AI as one, that are trying to also implement API-driven data science. So how about the technology? Are we there yet? I think some of the gaps in the technology has led to some anti-patterns. These are some that I have seen. I almost didn't want to put these labels on the slide because I thought, oh my God, we're going to create new memes, and that could be quite dangerous. So some of the patterns is a single cloud data mesh. So as long as your data exists on a same cloud provider, you can get data mesh. As soon as you go hybrid or across cloud, it can get quite hairy. Single vendor data mesh, as long as your data is on a single platform, you can share your data, but across platforms, probably not. And that's actually quite a point of friction in some of the clients that we have. They've started data mesh on one platform, but then the rest of the organization is not happy because they want data sharing across platforms. And the last one is a very dangerous one, which is data mesh off the back of the pipeline. So you're still doing pipelining data from applications, putting in lakehouse, warehouse, and then downstream you have this beautiful data product. Please do not do that. Pipelines and data mesh do not go into one sentence. They should not go into one sentence. And there are other ones that I won't bore you with, but they're out there. So why we see these anti-patterns? Because we still have gaps in the technology. There is still the high cost of integration for this peer-to-peer analytical data sharing. For one, we're missing the technology that connects data consumers and data providers directly for analytical use cases, a technology that concerns itself with data product as a first-class concern. We are missing the analytical data APIs, and I almost want to avoid using sharing because it provokes this idea that we have to keep moving data around to share it, and we've got to start thinking about how we can share the data without really moving it around. So we've got to define these more computational APIs to get the computation closer to the data. And I've put a few other kind of characteristics that I think should be embedded in a distributed data sharing API, and I cover that in details in the book. So we are still working on those APIs. The integration of existing technology into a new topology is quite costly, and I've had that experience firsthand. Hundreds of millions of dollars spent. 3 years later, we've built a platform for one of our customers, one of my previous customers, that was integrating existing technology that has been designed for that pipeline operating model into a mesh operating model. And finally, there are also hard limitations. Many of your cloud providers never assumed you will have hundreds and hundreds of lake storage, so you simply run out of accounts. So we still have work to do. So what is our North Star? Where do you want to get? I think North Star is still a place of imagination, It's a world of imagination we have to get to, but without imagination, we also get nowhere. So let me introduce a fictional story of a data mesh implemented. I use this story of a digital streaming system in the book, and I put here as an example of that. What we want is these cross-functional teams, that people that are mission-oriented, and the mission is the mission of the outcome of a business unit they are working within. So tech-aligned, business-aligned tech teams. Here I give an example of for example, a playlist team in Spotify that want to share specialized or hyper-specialized playlists for their audience and for the listeners. They have some data to share, they have some application services, but their objective, no matter they're working with data or applications, is create this immersive, context-aware experience for the listeners. If they need to make their playlists a bit smarter to be aware of the context of the partner platforms, whether as a listener I'm on Peloton or some yoga studio, they can peer-to-peer work with the partnership team whose outcome that they're looking for is this integrated experience no matter where these listeners are. So they're incentivized to provide data to improve the playlist experience, and so on and so on. So we want embedded AI and data in every domain. We want to remove the friction of data culture, data sharing, so we can be data curious, go from the hypothesis to that value very quickly. I almost didn't put any tech in this diagram because I think technology needs to disappear into the background. Enough of talking about platform X or platform Y. If technology is designed for the best developer experience, it almost has to be invisible in this diagram. We want limitless scale based on this network value sharing of data products. And if new functions of business appear, we bring up new domains, new cross-functional teams, new ownership for a new set of data products. So how do we measure? How do we know we are moving toward this target state? In the book, I put a lot of different KPIs, and I introduced them based on the pillar. But I think if you want to take a few KPIs away to measure and implement it for yourself, I go back to this trusty source, which is a few years old. The book Accelerate came out of many years of research in DevOps for software engineering, and what they found out was the differentiation between high-performing, medium, and low-performing organizations. Out of 28 metrics that they collected, came down to 4 metrics. So let's apply those 4 metrics to data mesh. The 4 metrics fall into 2 categories, tempo and resiliency. On the tempo, reducing lead time from data, from a moment that a piece of data changes to the point that data gets applied in some machine learning model trained and inference is made on that data. Are we reducing that lead time? How often are we changing data products? We want to make that change as often as possible because nothing is constant. Data is changing, schemas are changing. How often are we able to change that? And when we make those changes, let's look at the resiliency. What is the change-fail ratio of these data products? How often a change upstream to an application has cascading effects down a pipeline, pipeline's failing, nobody knows exactly what's going on. A week later, maybe we find out. And if it fails, failure happens, let's reduce the mean time to recovery. How long does it take for us to reduce that? So I challenge you that if you're applying data mesh, we've got to increase the metrics on the left-hand side and decrease the metrics on the right-hand side of this diagram. So by this point, you might think, okay, this is quite dire scene. But we've made a lot of progress. It's only been a handful of years. We've got plenty of opportunity, as John Adams said, the founding father, one of the founding fathers of the US, that every problem and challenge is an opportunity. And I think we are at a rare moment in time. There is ubiquitous need for change, how we imagine data sharing. Clearly, there is white space for innovation. we have a big vision, we have a big North Star to get to. So let's create some magic together. And if you want to be part of our team, come and talk to me as a founding engineer or a design partner. Thank you very much.